So now that I've got my methods all sketched out and my class defined properly, let's think for a moment about what sort of member variables I need inside of this class. So the first thing I'm going to do is going to be inspired by the book a little bit. I'm going to add in a constant that'll keep track of what the default capacity of the array that implements the stack is going to be. So in here I'll do my private final, because I want a constant static int default. Let's go to default cap equal 100. So what we're doing here is we're just defining a variable, right, an integer variable, to store this kind of magic number, right, that we want to have every stack that we build, right, when we make stacks for the first time using the new keyword, each of them should be initialized with an array inside that stores 100 elements. That's the meaning of this line. And maybe if we want to have arrays be bigger, right, if we want to have the array be bigger, then we would increase this to be something like 1,000. But for now, we can just leave it at 100. That's fine. After that, I need a couple more variables. The first thing I'm going to do is make a variable for actually storing the information inside the stack, right? So I need to have an array that stores the stuff the stack has. Over here, I've gone ahead and typed in private. And then what I'm going to do is I'm going to give it the type T, because at this point in time, I don't really know what this stack is going to be stored, right? So I'm going to use that generic type T to say that, oh, well, I don't know that type yet. At some point in the future, the user will define what it is, and then Java will go through here and replace the T's with what it actually ends up being. Since I want an array, I'll go ahead and put in my brackets too. And then I'll give this a name, and I'll just call this stack. So this is going to be the information, right, that makes up that contents of that stack. Given that I have the stack, the other thing that I want is some sort of variable to keep track of how much of that array has been used up. And so what I'm going to do is I'm going to put in a variable called top. This will be an integer. And what this will be is this here will be an index, right? It'll be an index into the stack array where that index is going to represent two things. First, how many things are in that stack. Second, what is the index of the next space I should put in an element. And if you think about it, the reason those two things kind of work out is because arrays end up starting at 0, right? So if we have one thing in the stack, right, top would be equal to 1, which is kind of the number of elements in there. But then 1, right, 1 is going to point at the second index inside a stack, which is going to be that blank space, right, after the one that's already there. It's going to be the space where we can actually add the next element, right, where we can add element 2. So just because arrays are 0-based, those things kind of match up, right? Size and next index end up being the same thing. At this point, I think our variable is looking pretty good. So let's think about doing a constructor, or let's compile first. All right, looks good. Now time for the constructor. Let's go in here. We're going to do a couple of them. We're going to do a default constructor and then one constructor that has a parameter. So the first thing I'm going to do is put in my default constructor, right? The one that doesn't have any parameters. So over here, I'm going to type in public, then I'll go stack array, right? So that's going to be my constructor definition. I don't need to have a type in there because I'm making a constructor, not a method. For this one, it's going to be default, so I'm just going to put in my parentheses there. I'm not going to give it any sort of variables. And then the body of this, I'll end up leaving this blank for a second. Let me actually start the other constructor as well. So what I want to do is I'm going to have these two constructors, and then I'm going to make one call the other, because I really don't want to implement the contents of the constructor twice. So it'll be better if I just kind of try to reuse stuff. So over here I have this kind of default constructor, and then I have the other constructor which takes in a variable called cap. So what this is going to represent is that I have some sort of fixed capacity that this array should hold. And I'm just going to pass it in via cap. So over here in my default constructor, what I'm going to type is this. I'm going to literally write the word this, and then I'm going to type in here default cap semicolon. So what this line is saying is the following. When you call a default constructor, you should essentially go to the other constructor. So when we write the word this, right, it's referring to the class that you're inside of. So when we have the word this here, it's going to actually look for the other constructor within this same class. And then it's going to defer to that one, right? It's going to let that one process this call to make the object. But that second constructor that we have actually has a parameter associated with it, right? Because this was the default one. The one over here that we have actually requires a parameter. So over here, right, that means we have to pass in default cap, right? So we're going to say, run the other constructor, and then give it that 100, right? So give it that default capacity that it should set up the array for. And that'll do it for our default constructor, since we're not actually going to implement anything there. We're just going to kind of defer to the other constructor to actually implement that code for setting up the array. So going over to the other constructor, we need to think about doing two things. First thing is we need to set up stack. Second thing is we need to set up top. Top will actually be the easiest one, so we can do that really quick. Top, if we think about it, since top represents the number of elements that are in the array when this thing is built, we want to initialize it to be 0. So we'll go top equals 0, just to represent that there's nothing in there at the very beginning. And then the next line is going to be a little bit complicated. For this line, I want to set up the array that I created earlier, right? The stack array. So I'm going to start typing this out. Stack equal, and then I'm going to type something that we haven't seen before. I'm going to do a cast, but a cast for an array type. So I'm going to do my parenthesis, then I'm going to put my T, and then I'm going to put my square brackets. So whatever type it is, it's going to end up being over here, right? When I type in this stuff over here where these Z's are, whatever ends up being over there, it's going to be cast to be an array of type T. And again, this is something you haven't really seen before. It turns out that there's kind of a limitation in Java that makes it hard to create arrays inside of a class when the type of thing you want to store in those arrays is a generic type. Because of that, our little line here that we're going to write is going to be a little bit convoluted. So now that we have our cast in, we need to actually write our allocation, right? We need to write our new keyword here. And I put in parentheses here just to kind of delineate what is the part here that's referring to the array creation versus the array cast. So in here, I'm then going to write new object, right? So I'm not using T here, I'm using object. And then I'll have my brackets again, and I'll put in the capacity. Right, how many elements I want to store in here. Let's compile this really quick. So it compiles. It gives us a little bit of a warning. We're not gonna worry about that right now. But this is going to be our line. This right-hand part here, in the parentheses, this here is saying, make me a new array that contains objects of size cap. Right, so all of a sudden I have this new array that's very generic, right? I can store an object in there or kind of anything that's a child of it, right? So literally I can store anything in there. But then what I'll do is I'm going to cast it to a type T, right? So even though it was built as an array of objects, since T is an object and all objects, right, or all classes are child classes of the object class, that means that I can store something of type T into any place they could store an object, right? Because object's a parent of T, of whatever the type ends up being in T. If this line seems a little bit off to you, don't worry about it right now. Again, this is kind of convoluted due to some limitations in Java itself. So that constructor now looks good. Let's think about implementing push. So for push, what I want to do is I want to take in an element, right, that parameter called element, and I want to add that to the array that's storing the stack information. And earlier we said, what we'll do is we'll keep a top variable around, and that top variable is going to represent the size of the structure of this collection as well as the next slot to store something. So my first line here is going to be relatively simple. I'm simply going to go stack at position top equal element. And since I've added an element to this array, what I'll need to do is I'll need to increase top, right, to represent that I've loaded one more thing into this array. If you recall from the previous section, this method can be a little bit problematic. Remember that since we're implementing this using an array, there's a chance we might run out of room in that array. So what can we do? Well, let's suppose that we have another method called expand capacity. And let's just put this in here, right? So it's going to be wishful thinking. We'll say, we have something called public void expand. I guess we'll just do cap. I don't want to type that much. Expand cap. Right, so this here will increase array size. I don't have this thing implemented yet, but let's suppose we have it. Well, in that case, I can finish up push by doing the following. What I want to do is I want to check to see whether this collection is full, right? Meaning does top equal stack.length. So if it is, right, if those two things are equal, right, if top is already counting as many elements as that stack and whole, then what I'll do is I'll make a call to expand cap. So that there is now a foolproof implementation of push, right? So if we've run out of space, we'll expand the capacity. Otherwise, we store it into the top and then increment top to represent that we've added another element. But what about expand cap, you ask? Well, for that, we'll have to implement it too. This won't be too bad because we're actually going to be able to use a method from the Java API that'll help us out a lot. It'll actually let us make copies of arrays. So over here, I'm going to say stack equal, and I'm going to type in the following. Arrays dot copy of stack dot length times 2. So what this line is doing is the following. We're going to go to stack, and we're going to make a copy of it. And this copy of it, right, this method here that's available in the Java API, it's going to need 2 parameters. The first is an array. So this is actually going to be our stack, right? So this is where we're copying from, right? What is the source of our data? And then the second parameter over here is the actual length of the new array we want to create. So here we're saying, oh, that new array I want to copy that information into, that should be of length twice what the original stack was. So every time we're just doubling in size. So this method as a whole is going to return a new array that's twice as long as the original stack array, and then also which has that data that was stored in stack kind of still, there. It's been copied over as well. And then that new resize stack will store it back into the stack variable. And so that'll give us our new stack that contains twice as many elements, as well as has everything that was there before we ran this method. So that does it for our expand cap method. This leaves us with 2 more things we need to implement. We're going to take a look at pop and peek. I'm not going to talk about implementing isEmpty, size, or toString here because those are going to be available as homework questions for you guys. Before I continue, let me go ahead and do a quick compile. And over here, we're going to actually get an error. Cannot find symbol variable arrays. All right, so this method we used over here that was built into Java to expand the capacity of an array, we actually need to add a package to bring that in. So let me just scroll over here. Let me go back to the top, and we'll bring in the package that has that functionality that made the expand capacity method really easy to implement. So what I need to bring in here is going to be java.util.arrays. And that should bring in all that functionality that lets me manipulate arrays. So let's copy that. Let's compile that, and everything looks good. Scrolling down, let's go back over to pop, which is what we wanted to work on. So pop, unlike push, has a chance that it can fail, right? We said earlier that, if there's nothing on my stack, then push should throw an exception, right? Should let the user know that there has been a problem somewhere, right? There should have been elements in there, but there wasn't. So how do I do that? Well, I already have over here a method called isEmpty. So what if I just use that? So let's say I have an if statement that checks to see whether it's empty, and then if it does, it throws an exception. That should work fine, so let's go for that. So let's do this if here, and we'll go if is empty, then, right, the true branch is over here. Let's go throw new exception. Well, actually, we can do better than just exception, right? We actually have this other class over here, this other exception over here called empty collection exception. And that's actually what we want to throw, because that'll be more specific. We could just throw a general exception, but then that doesn't really tell us what specifically went wrong. Normally, if you're doing a kind of an error analysis, right, it's more useful for you to have the more specific information rather than something that's just general, right? Something that could have come from any other part of your program. Instead, we want to know specifically what went wrong. For example, there was an empty collection. And here as a parameter, we'll just say, it's a stack array. So it'll give us a little error message there telling us that our stack array was empty when we were trying to do a push on it. Now that I've got that set up, we can think about implementing the rest of this pop. So the purpose of pop was to reach in, take off the topmost element, return it, and at the same time remove it from this entire data structure. So let's see. What index is that element going to be stored at? Well, it's going to be at the element right underneath top, right? We said the top is the next empty space, so that means that the one below top, right, is where we're going to have this element that we want to get at. So what I'm going to actually start with here is by typing top minus minus. So when I do this, right, the first thing I'm saying is, there's one element less within this stack data structure. Well, not only that, but that top then is going to be pointing at the index that contains the element I should be returning from that call to pop. this is going to be useful for me, because what I can do is I can create a variable now and use top to figure out what should be stored in that variable that will hold the thing that was at the top of our data structure, or the top of our ADT. So let's write here t element equal stack of top. So the effect of this line here is going to be us taking whatever is in that topmost slot, right, the topmost occupied slot, and storing it into the variable called element. Now that I've taken out this element, I can return it, right? So I can go return of element. I think in the book they also have a step here where they do something like stack at top equal null, right, to replace the element that was in the stack with a null symbol. But you don't really need to do that. Basically, once you decrement top, once it goes down by one, that's essentially freeing up the space there, right? So when we put in something new, it's going to override whatever element is that just got popped off, right? So we don't really need to worry about resetting it with a null, because it'll be reset as soon as we need to use it. So that should do it for pop. So pop's looking pretty good. Let's try compiling. Still good. We keep on getting that warning there. That warning is just due to that constructor we wrote, which had to have that kind of convoluted code in order to set up the array of the generic type. So what about peek? Well, peek is going to be pretty much the same thing. So peek, let's see. Peek also has the issue where maybe somebody tries to run it and the collection's empty. So we'll go ahead and copy and paste in our code that dealt with that. So if empty, throw this exception. But then what we want to do is we want to return that topmost element, but not take it off, right? So that means we're not going to need to change top at all, right? Top should be the same. So what we can do is actually just return stack top, or stack top minus one. So stack top minus one is going to give us that the index of the element that was most recently added, right? The last thing in. If we just did top, it wouldn't work out for us because remember that top is pointing at the index of the next place you'd add an element. So that's not really what we want. We gotta instead do this top minus one. Let's go back and compile. Things still look good. What we want to do next is look at our driver class and do some testing of this thing. But I'm seeing one thing that's going to cause us a little bit of trouble in here for pop and peek. If we want to go and test these, they'll always throw an exception. Right now, they'll always throw an exception. Maybe take a second to think about why that would happen. The reason it happens is that over here in my isEmpty method that I was just filling in blindly, I put in the word true for the return type. So whenever isEmpty is called over here in pop and peek, that's going to end up being true, which will mean that this branch will be called, and that's not really what I want, right? Really, I want to make sure that I'm allowed to run these, right, so I can actually test them out. So over here, I'm going to just arbitrarily change isEmpty over to false. That way I can test those things without having to worry about them throwing exceptions.